Explain the video goal and say this will cover the learning path from fundamentals to building, evaluating, fine-tuning, and deploying large language models, plus ethics, tooling, and project ideas to build a portfolio. Start with prerequisites and mindset. Recommend learning basic programming in Python and comfort with the command line. Emphasize linear algebra, probability, statistics, and basic calculus as foundational skills. Encourage curiosity, patience, and incremental project work. Learn core machine learning fundamentals. Study supervised and unsupervised learning concepts. Learn optimization basics like gradient descent, loss functions, and regularization. Understand evaluation metrics like accuracy, precision, recall, and cross-validation. Master deep learning basics. Learn about neural networks, forward and backward propagation, activation functions, and common architectures. Study convolutional and recurrent networks as background before transformers. Get hands-on with frameworks such as PyTorch or TensorFlow and practice building small models. Study natural language processing fundamentals. Learn tokenization, embeddings, word vectors, and sequence modeling. Understand language tasks like classification, translation, summarization, and question answering. Explore common datasets and pre-processing steps. Dive into the transformer architecture. Read and understand attention mechanisms, self-attention, multi-head attention, positional encoding, encoder and decoder stacks. Study how transformers replace recurrence and why they scale well. Implement transformer components from scratch for learning purposes. Learn about training large language models. Understand pre-training objectives such as language modeling, masked language modeling, and next token prediction. Study datasets used for pre-training and the importance of data quality and filtering. Learn about batch size, learning rate scheduling, and optimizer choices like add-in variants. Explore fine-tuning and transfer learning. Practice fine-tuning pre-trained models for downstream tasks using libraries like Hugging Face. Learn parameter efficient fine-tuning methods such as adapters, low RA, and prompt tuning. Understand domain adaptation and few-shot learning. Master tokenization and data pipelines. Learn different tokenizers, byte pair encoding, sentence piece, and tokenizer trade-offs. Build data pipelines for large corpora handling, sharding, streaming, and on-the-fly augmentation. Ensure reproducible pre-processing and dataset versioning. Learn evaluation and benchmarking. Understand automated metrics like Blur Rouge, perplexity, and newer task-specific metrics. Learn human evaluation design, A/B testing, and significance testing for model comparisons. Track robustness, fairness, and toxicity metrics. Study model scaling and compute considerations. Learn how model size affects capabilities and cost. Explore techniques to reduce resource needs such as mixed precision training, gradient checkpointing, and activation recomputation. Understand distributed training basics, data parallelism, model parallelism, and sharding. Explore inference optimization and production readiness. Learn quantization, pruning, distillation, and batching strategies for lower latency and cost. Study serving architectures with GPU and CPU inference and edge deployment trade-offs. Implement caching and request routing patterns for real-time systems. Learn ML ops and tooling. Understand experiment tracking, model versioning, and reproducible training. Use tools for logging and orchestration like weights and biases, Morphflow or similar. Learn CCD for models, dataset governance, and automated model evaluation pipelines. Study safety, ethics, and alignment. Learn about bias mitigation, adversarial examples, prompt injection, and content moderation strategies. Understand privacy-preserving techniques like differential privacy and secure aggregation. Study legal and policy aspects of data usage and model outputs. Practice with hands-on projects. Start with small projects like text classification, summarization, or chatbot fine-tuning. Move to larger projects like retrieval augmented generation, domain-specific assistance, and multi-step pipelines. Build end-to-end demos with front-end UI and a hosted backend. Build a portfolio and soft skills. Document projects with read, write blog posts, and create short demo videos. Share notebooks on GitHub and models on Model Hubs. Contribute to open source and participate in community challenges and hackathons. Plan compute and cost management. Learn cloud basics for GPU instances and spot pricing. Use local smaller models for experimentation and scale gradually for larger experiments. Budget for storage, compute, and monitoring, and learn to profile and optimize resource usage. Gather recommended resources. Suggest textbooks on deep learning and NLP, online courses from reputable universities, practical tutorials, and official framework docs. Follow active research via archive conference papers and community blogs. Use curated learning paths and mentorship when possible. Summarize the learning path. Reinforce the sequence fundamentals programming, deep learning NLP transformers pre-training fine-tuning evaluation deployment MLOps and ethics emphasize building projects and learning incremental scaling visual suggestions for the video input show a roadmap graphic progressing from fundamentals to deployment show animated diagrams of attention and transformer blocks show code editing and model training dashboards and experiment tracking screens show dataset pipelines tokenization visuals and data cleaning steps show performance charts for metrics and comparisons show demos of Chat UI or Search Assistant and a final portfolio showcase. Use this full script as the video input for Pictory.ai to generate an educational explainer about a complete roadmap to learn large language models and move from beginner to practitioner.